Okay, for this video, we're going to solve a polynomial by grouping. So the first thing it is, you need four terms over here. So you might or might not need to split the middle term into two terms over here. And then we're going to factor for some high degree polynomial if there are four terms. So let's see the first example over here. So we're going to find the greatest common factor for the first two and the last two over here. So maybe use a different color. So for the first two over here, we have x cubed and x squared. So the greatest common factor will be x squared. And we get x plus 1 here. Then we are going to subtract 9x minus 9 over here, which is negative 9. We got x plus 1. So I will say 100% you will see the common factor over here, or you're gonna redo your question. Otherwise, we can not really solve the polynomial. So in this case, we got x plus, let me use pink color over here to distinguish. So I got x plus 1 over here. Then the other factor we got over here will be x squared minus 9 equals 0. Since these are x squared and 9, they're all perfect square, which means I can keep factoring, use a plus b times a minus b equals a squared minus b squared. So we got x plus 1 times x plus 3 times x minus 3 equals 0. So we got 3 factor over here, and we're going to let each one equal 0. So if this equals 0, we got x equals negative 1. If the second one equals 0 over here, x equals negative 3. The last one over here, if x minus 3 equals 0, x equals 3. So for the first question over here, your three solutions are negative 1, negative 3, and 3. For the next one, let's see. For this one, we're going to do exactly the same thing. Find the GCF for the first two, find the GCF for the last two over here. So we have x squared times x plus 3. And we have negative 25 times x plus 3 equals 0. So we got a common factor over here, x plus 3. And we're going to times x squared minus 25. X squared and 25, they're all perfect square. And the difference over here, I can rewrite as x plus 5 times x minus 5 equals 0. So in this case, I'm going to let each factor equal 0. So if this equals 0, x plus 3 equals 0 means x equals negative 3. X plus 5 equals 3 equals 0. X equals negative 5. Same with the last one. X minus 5 equals 0. X equals 2 positive 5. So the solution set over here will be negative 3, negative 5, and 5. Show me one more over here. So for this one, we're going to have x 3x cubed and minus 6x squared. We're going to find the GCF. Then we're going to find the GCF for 27x plus 54. So we have 3x squared times x minus 2 minus 27 times x minus 2 over here equals 0. So the common factor over here will be x minus 2. So we have x minus 2 times 3x squared minus 27. So you can factor it out a little bit. So 3x squared minus 27, you can find the greatest common factor by 3. So we have x minus 2 times 3 x squared minus 9 equals 0. X squared and 9 are all perfect squares. So we have 3 times x minus 2 times x plus 3 times x minus 3. So in this case, we let each factor equal 0. So we got x equals 2, x equals -3, x equals +3. So the solution set will be 2, 3, and -3. So give it a try for question 4, 5, and 6, and I will see you in the next one.